This is the demonstration for Microcontrollers 2, Project 3, Group 3, Part 1. The purpose of this code is to compare the most significant bit and the least significant bit coming into pins 7 and 8, and then determining the frequency based on the combination of those two bits, and then outputting the duty cycle and the pulse width depending on the rotation of this potentiometer. Right now we have the most significant bit and the least significant bit set to low, so that would output a frequency of 0. As you can see, as I change the pot, the lights do not come on, and the serial monitor indicates that the pulse width and the duty cycle are 0. Now if I were to put the least significant bit low and the most significant bit high, that puts a frequency of a frequency of 1 and a time of 1 second. Right now there is a 90% duty cycle and a 10% pulse width. As I adjust the pot, the pulse width and duty cycle begin to change until they reach a certain value where there is 100% pulse width and no duty cycle. If I were to put both high, we get a time of 10 milliseconds or a frequency of 100 hertz as displayed on the serial monitor. Because we have the pot set so that there's no duty cycle, we must turn it, and goes up to a 90% duty cycle displayed here. The last setting is a 60 hertz frequency, or a 16.67 millisecond frequency, and as you can see, we are back to having a pulse width of 16.67 milliseconds and a duty cycle of 0. As we turn the pot, it increases the duty cycle up to 90%, which is 15 milliseconds, and a pulse width of 1.67 milliseconds. And we'll set those back to ground again. Indicating it is 0.